Okay, so we're getting started. My name is Ben, and I have here Sidharth and Vikram. And so we're going to be doing a talk today about why you might want to learn computer science if you're a elementary, middle, or high school student, even if maybe you don't know whether you want to be a software engineer or something like that. And actually, Sidharth and Vikram have some things to say about their experiences, because like you guys didn't just do, for example, apps or something like that with your programming skills or maybe your like problem-solving skills. So maybe you can tell us a little bit about who you are and also talk about like why do you find coding exciting, even if you're not always just doing stereotypical programming.
Right, yeah. So my name is Sidharth. I am a rising junior in Lexington High School, and I've done things with computer science, including I've participated in the National Invention Convention, where the task is to build an invention that can change the world. And using computer science, I've been able to build a pair of glasses that you can actually blind people can use to find to help them navigate through hallways and busy streets, because it will give off the distance between the user and obstacles around them. And computer science is a big part in getting that product to work. And computer science is also a big part in an internship I recently did at MIT, where I helped write code for an aircraft that was designed to fly for days at a time.
And you said you really like aerospace engineering, right?
Right.
And like, I guess, first of all, what is that? Because I guess not everyone's familiar with that term. And then I guess, what do you find that's so cool about it?
Right. So aerospace engineering is like it's engineering in the field of aircraft, like planes, rockets, satellites, anything that like basically is in the sky or above. That classifies, I guess, as aerospace engineering.
Cool.
So and the reason why I like it is to be honest, I'm not entirely sure why I love aerospace engineering. I loved planes since I was a young kid. And it just has kind of grown over time to the point where I realized that I want to do something with that in my career.
And so aerospace engineering, probably pretty different from making an iPhone app, maybe, but maybe not. How do you think you might be able to use some of your CS skills towards that kind of passion?
Towards aerospace.
Yeah.
Yeah. So for example, like just an example, if you're designing an aircraft, let's design the next fastest plane in the world. And to make that, we want a plane that's light, a plane that's not heavy. And to do that, there's a certain optimum length of the plane, the wingspan. You can make any wingspan you want. There's a very specific dimension of the aircraft that will always be the most optimal and most efficient. Now, you can, on paper, you can go and like try to find that yourself, or you can use computer science. And what I've worked on is using a software to actually write code that will basically, you plug in parameters and it'll build like the dimensions of an aircraft for you, and you can use that to then build your own aircraft that will be the fastest plane in the world while not compromising drag or like wasting too much material.
So I guess simulation is not just for like Minecraft, it can be also used for these like engineering applications.
Definitely, yeah.
Cool. So, and we also have Vikram here. I guess you've done some programming as well. Can you talk about some of the things you've done and like what have been your experiences so far?
So I took some classes at KTBYTE here, and I haven't like gone the way that Sid has, but I have like been TAs, and I even helped with KTBYTE website.
Mm-hmm.
So yeah, I sort of just like do something that interests me. Mm-hmm. I also like math. I like math and I like cards, so it all sort of ties in.
Cool. And you're going into 7th grade, and you guys have slightly different interests. You I guess notice like you both are learning if statements, for loops, those kind of things. But do you feel like you have different interests from Sidharth?
Yeah, I don't.
I would say yeah.
Okay, cool. So today we're going to talk a little bit about what you might be able to learn, how you might be able to apply these skills, and also just how to look at the world around us as it's changing and developing. And so a lot of people think of CS as a STEM thing. And if you maybe want to go into sociology or linguistics, or maybe you want to go into some kind of fine arts, or you like some specific project, you might not automatically think, oh, I want to do CS. So we're going to talk about that. And like I said before, right before we started, if you have any questions, just type it on the box on the right. We'll try to get to it as quickly as possible. So give me just a second while we turn on the slides. Okay, cool. So great. So coding and computer science are not the same thing. And I guess I'll speak first from my experience before passing it to you two. So when I was in college, one of the things that sometimes surprised me is when I was taking a computer science class, we would have no computers. So we do it using pencil and paper. And I think now a lot of our students are becoming aware of that at an earlier age, that it's the problem-solving process. So obviously you can use a computer. You can convert a problem like designing an airplane into a computer problem. But you can also think about, like, how would you solve that in a rigorous, mechanical, part-by-part problem-solving way that breaks down the bigger problem into smaller problems and tries to achieve goals such as optimizing certain variables or making certain things to be the most efficient, like you mentioned. And so when you take these computer science classes, I was surprised that, like, we talked about optimization, we talked about computational complexity, we talked about how algorithms could solve real-world problems without a programming language in mind. And so a lot of computer science is thinking about how, and that's why in some schools it's part of like an information science. It's how is the world built out of information? And that information can be an airplane, it can be the CGI in a movie, it can be the genetic tree of an animal, it can be all these sorts of things that one might not think of because one might not interact with them through a computer. And so because we catalog things, we record things, there's a lot of data, there's a lot of models, there's a lot of theories that can be described as information. Computer science touches all of those types of things. So you mentioned aeroscience. Have you done some musical problems either of you two?
Yeah.
Yes. Yeah. When you did like the USA Computing Olympiad, that contest kind of, I know I'm just throwing this on you, I didn't ask you beforehand, but like what might have surprised you about the way the problems were worded, or like, you know, what the form factor of the problems were? Like they're not like make this app, right?
Yeah, they're not. They're more of like solve this problem and like, so yeah, like solve this problem. How would you do this?
Mhm.
And they're not really realistic. It's sort of like, how can this cow build a house?
Yeah, they're all cow related.
Yeah. Farmer Joe.
So the USA Computing Olympiad is based in Wisconsin, I guess, so there is a bit of that. And so, like, find a house. And so, what does, like, a cow finding a house, what does that have to do with computer science? I know you didn't pick a specific problem, but, like, how is a cow information? Or how is a house information? Like, how did these things become variables or things inside the computer? Do you have any ideas about how that might occur?
So I think using like how we think these different variables. Yeah. So I think like really it's about like taking something that like a problem you want to see that you want to solve, and I guess finding a very systematic and meaningful way to approach it. So rather than just going and trying like all these different things, like I think if you're trying to like let a cow figure out the size, the best house to build for that can fit in the farm, I guess a computer you should think like you should think like a computer. So you should go and you should break down the problem into smaller pieces. You should do systematically. You think, where should I start? And you figure out the smartest place to start. You want to figure out the smartest way to like try different things to figure out what the solution is. Because in the end, time and resources are limited. So if you can find an efficient way to solve your problem like a computer, you can find the best and most efficient solution.
So you're talking about methods, which perhaps in computer science we would call functions, and ways to express it, which maybe in computer science we would call data structures. You said you made some glasses, Sidharth. What were some of the information you need to store? What were some of the decisions and functions you need to make given that problem.
Right. So generally, so basically the main purpose of the project was to allow the blind to navigate. So the blind, they don't. If you assume that they can't see, they can't see, right? So they only have 4 senses left. So the thing is we have to utilize all 4 of those senses so that it's maximum. So we can do maybe touch or smell. Oh, sorry, not taste or smell, but for touch and hearing, we can do that. So basically, when you use the glasses, it has a sonar, which is or an ultrasonic sonar. And generally, what it does is it sends out a sound wave, and when it returns, it finds the time it took for that wave to return, and it can calculate that into distance. And then once you know that your parameter or your input is distance, and you want to output something to let the blind know that, hey, there's a wall in front of you. So then you can convert that distance into a sound frequency. So there's a scale of sound, a range you have for sound or pitches you can use, and you figure out what pitch you want to correlate or correspond to that certain distance value. And once you can find that, you can display it. You can just play that pitch on a speaker, and using that you can take a parameter as an input, which is distance. You do something to it, which is figuring out what frequency you want, and then you output it in the form of a sound or a beep, and it's just how it's used.
Cool. So you're basically taking the problem of navigating for the blind and converting it to an information problem by which the information is this distance, and then the user interaction is how you present that information to the user, how you translate or convert that information at distance into something that the user can make decisions on. And so that's a pretty common theme in computer science. And when did you do this project?
I did this in 9th grade, so around 2 years ago.
Okay. So right now you're a junior. Never do math live. So a rising junior, 9 plus 2. Okay. So I guess Vikram, sorry, you said you were going into 7th grade. So you guys are starting pretty early, thinking about these information problems and how to convert them from one thing to another. Do you feel like it was just like one day immediately you clicked that everything is information, or how did you go about understanding the way in which you look at the world in terms of this is information, that's information, these are functions? Like what was the process like? Do you feel like, when did you start, for example? What was the time in which you began doing CS and thinking about these kinds of problems?
So I think the first time was around, sometime in middle school. I think it was the summer before 7th grade. And for me, what happened was I did like some robotics campus. I can't remember where, but it was some small camp. They taught to use like these small computer chips. And I kind of looked at it and I was like, okay, that's kind of cool. And then I think there's one thing where they're teaching you how to use like a thermometer to like record the temperature in a room. And I think that kind of blew me away, because then I kind of realized you can take something like a temperature and you can print it out on an LCD screen. And that was like one of those like aha eureka moments for me, because then I thought, oh, you can think of it like you can think of things in your world around you. You can perceive it like a computer would perceive it. And from there I kind of started building up my knowledge, and I kept going into classes at KTBYTE, and then through that I'm starting to understand more how like computers perceive the world, and I'm starting to think of myself like a computer and how I can perceive the world, and then probably do something like take an input to do something to a given output, like simply like a function.
And does this surprise either of you that, like, I know when I was younger, I didn't realize how many things in the world were shaped, designed, engineered by computers. Some things as perhaps commonplace as like a chair, or certainly as commonplace as like a car. So we have lots of computers. Chairs often, like some of the stress and strain modeling is done on computers. Like, can you share maybe some experiences and you're like, oh, like that's cool. That's related to computer science, and maybe.
Yeah. Before I like learned computer science, I used to take like everything we had for granted. I never really understood how things worked. But now that like I know computer science, I know from Java, I'm sort of like, oh, this is how the computer works, this is how the car works, these are how doorbell works. I never really knew that, and it's like, oh, that's pretty cool. I kind of want to learn it.
Mm-hmm. And you said Python and Java, but do you think the language that you're learning is really that important?
Not really.
And why is that?
It's sort of like they all kind of function the same way. I mean, they're structured differently and they can do different things, but they all sort of like run a code and they do a certain function.
And so, like, for example, like maybe a doorbell, especially like an electronic doorbell or something like that. Now that you've learned some CS, like when you see these everyday objects, you know, how do you feel about it? Do you feel like it's a little bit less mysterious maybe than before?
Yeah. I'm like, oh, okay, this is how it works. This is how it can do it. Okay. Before I'm like, huh, how could it do that? Is there like a sensor? Is it magic?
Yeah, yeah. And so a lot of people, so I'm over 30 now, and so a lot of people my age might have learned computer science in college, and you guys are doing it in middle school, and you know, how does that shape kind of what you think you might want to do in the future? Like Sidharth, you mentioned you might do some CS related stuff in the future, different units that as well. Like, do you guys see yourself? Are you set on a career? Are you set on like a major? Do you feel like at least you want to do some project, or did you like? How does that shape what you think about in terms of your future?
Yeah. So I think like I really strongly believe that in my future, whatever I do, I know that it will be doing something with computer science. I know that I'm gonna go probably into the STEM field, and if I want to like go in the future and maybe even build the next fastest jet, I know that I'm gonna need computer science to do that. I'm gonna need to figure out how much fuel they need to give, how much thrust does the engine need to create. I need to really think about a lot about more. I'm gonna definitely think about a lot of things as if I was a computer to find the best solution to of any problem that comes in my way.
Okay, cool. And so, how about you?
For me, I don't know what I'm gonna do, but I know that like it's going to be CS related. Same with him. It's like it's gonna be CS related, STEM related. It'll be something along those lines. We're not completely clear on what it will be.
Yeah, so I guess it's pretty cool because like you guys are having more options available. You're probably also pretty confident about doing programming. I know a lot of kids your age, programming is a scary thing. And do you feel like starting early has made it easier for you in high school, for example? You're in high school, Sarah.
I definitely feel like starting early in computer science really is I would say it's very important. I would say it's very important to do that because I feel like in anything that you do, computer science is just somehow related to it. And even like if you're like I study economics, and even then like computer science trying to figure out what stocks to invest in or what company or even like finance what companies you want to invest in. Like that computer science can play a big role into that, especially with the rise of machine learning. That definitely is a growing field, and I also think that things like even like topics you wouldn't expect computer science to be in, they still are there. Like violin, and I play the violin, and whenever I put my fingers down on the violin, like I always think of it like as a computer, like a function. Like if this note put here, and it's like you kind of think of it like a computer. And even though it's not directly correlated or tied to it, it definitely like I guess theoretically it is kind of related to each other.
So you feel like you're getting more confident, and that's really inspiring, I guess. But you mentioned you guys are doing some activities. So our slide here says, for example, leadership. What do you think it gives you the confidence to take leadership positions or confidence to do certain kinds of activities?
Definitely, yeah. I mean, so I have started a group at a class at KTBYTE called the Robotics class, and what we do there is we basically teach things like we basically teach computer science, but not we don't. In addition to that, we kind of teach a lot of hardware things as well. So we go around and we tell people how to build inventions and build things that are that can just benefit other people, or just devices that can help other people. So on the video right now, those are actually my glasses that will help the blind see. I think it's going to give a demonstration right now. So this is an example of an invention out there that I've created. And in the robotics class, we encourage other students as well to create their own inventions that can help other people. So definitely, leadership comes through that, where I definitely think that leadership does come into play when doing once you know computer science, because like you can basically run your own classes and write your own curriculum, which is what we've done here with the robotics class.
Cool. And so I guess you're talking about this robotics class, and what's it like, kind of, now that you've learned CS early, being able to collaborate with other students, maybe helping to teach a little bit, also just working on things with friends? Do you think it's like improved your social life or improved some of like your high school activities, that kind of thing?
I definitely think like like I would say robotics club was probably one of the highlights from my 10th grade, from my life in 10th grade. And I would say this probably because I got to work with like really amazing people, especially like our TAs who have been there helping other students, and also the students itself. Like, I'm always very excited to have a new class fresh with students where each person has a different personality, and we can go and we can really understand them and try to help them build a project that would really be meaningful. And in the end, I think the second picture on the left column, we all went to Detroit for a national competition, and then I feel like we kind of bonded as a family when we went there, and we've been there for a year. We've been working on these projects and building these things so that like the experience of computer science, it will kind of like be able to help you build your own things and kind of definitely network and socialize with other people.
Okay, so, and Vikram, you said you wanted to do some competitions. You're looking forward to some things as well, right?
Yeah, I would like to do Yusuko, because although the problems aren't realistic, like cows teleporting and stuff, it still does help me with computer science and helps me like view the world in a different way. Yeah. Yeah.
Were there any other competitions? I'm just wondering this.
I did also want to do NICEE, so that it sort of challenged me to build something, and then they'll help me.
Cool, cool. Okay, so and we have a few pictures of some of our past students and who've given some seminars as well, and all the people in these images are in college, and I think what maybe surprised some people, but actually didn't surprise us, is that half of them aren't studying CS, at least as a major. So they're studying, for example, neuroscience. That's what Patrick is studying. Or like Kristen's in mechanical engineering. Or William is a humanities major at MIT. And I think Vishnu is doing English and CS. And it surprised us to a degree maybe that it was so deeply in the humanities, some of their work. For example, William really likes to make applications that allow writers, storytellers to be able to more creatively create their prose, maybe even automatically generate pieces of prose, annotate their poems or their stories. Patrick was trying to apply CS towards both models of neurological systems, but also to allow him to apply towards undergraduate research labs. And so I think a lot of our students actually don't want to major in CS, but they use CS as, I mean, not just a tool, but like kind of, like you said, the way that you look at the world, right, Sidharth, so that you can do any kind of major. And I guess it's a little bit early for you guys to think about your major necessarily. Like a lot of people your age, you don't know what you're going to do in college, whatever. But you mentioned economics. You mentioned a little bit of like engineering. Again, I'm throwing another random one at you. Do you feel like there are other majors that you've thought about and you're like, oh, like maybe I could do that, or maybe a minor in that, or something like that?
Yeah, actually, I even first thought that I was going to do just computer science as a major, but then I realized, I looked into it, I thought just because it's computers and everything, there are many other fields that include it. So, for example, I thought aerospace engineering was just testing planes, and then computer science is just writing code. But then I realized that these things, they all kind of tie into each other. So aerospace engineering is not just like building model plane and throwing it off a building. It's a lot of like using computer science and code to really create different things. And so the same thing goes for economics. So I feel like before I definitely thought only computer science is the only place to go, but definitely like there are many fields out there that also include computer science. And I think even in the future, within the next 10 years, I don't know the age group that our viewers are right now, but in the next 10 to 15 years, computer science is going to become a greater part of more fields of study. I think that just especially with machine learning, that's
sure. I know that when I was studying computer science in college, my specialization in CS, this was back in like 2005, was actually sociology. I was particularly interested in human networks. And a lot of that, I guess, seems antiquated now in the sense that everyone has used social media. Everyone knows how groups work online, propagation of ideas online. Memes are like obviously a thing, right? And even concepts from sociology, such as social balance theory, propagation of diseases through interpersonal connections, propagation of ideas, or even other kinds of information through corporations or institutions. These things were novel ideas in computer science, I think, when I was studying them it's over a decade ago now. But now computational sociology is a fairly well-established field, and obviously all these large companies that are in the social media space are applying these concepts, specifically graph theory, on their everyday applications. And so, there's computational linguistics, which allows for natural language processing, bioinformatics, which allows you to do gene sequencing and look at different kinds of genetic questions without having to necessarily do wet lab work. There's computational physics, which allows you to simulate different kinds of materials. This is particularly useful for testing new types of materials without necessarily having to go through the fabrication process. It's not just for 3D printing. Like even in your industrial applications, even in your nano applications, you're still going to want to run through computer models. And so a lot of people who are in the hard sciences, soft sciences, I was surprised, for example, like computational archaeology, when we were researching for today's talk, that was a thing. That was not merely a thing, but it's actually a major at several schools. And so really CS has penetrated a lot of fields. One thing that we didn't really make a slide about was its impact on some of the fine arts. And it's actually quite enormous, the impact on, I think everyone knows about CGI, Pixar. A lot of people have interacted with automated or generative design situations. Obviously, online media is graphs and other kinds of like communication channels are incredibly common. And so, but we didn't have a slide on that mainly because it's just so diverse at this point and we couldn't include everything. So even in the soft sciences and even in the arts. And we have this slide here, which is talking about industries. On the left side, we have, for example, industries that are going under or are predicted to be computerized. And so a lot of them are surprising, like paralegal work. A lot of paralegal work is research, and natural language processing has improved so much that a lot of the, for example, case research or discovery that lawyers might have to do now can be done through very, very intelligent search engines or very, very intelligent recommendation engines. And on the right side, we have a 2014 survey of top software companies by revenue. And what may surprise you is that the 91st one, not the top one was Microsoft. Top two, I think, was for IBM. But the 91st one was Amazon. So a lot of these other big ones, like customer relationship management, Salesforce, or accounting, payroll, compliance, retail, or like electronic medical records, are very large. And so it's sometimes shocking how computer science has penetrated all these various fields. So if you're a parent and you're talking about your kid learning computer science, if they say, like, I want to go to business, absolutely. If they say, I want to go into medicine, maybe even not on the research side, even on the practical, delivery side, there's a lot of personalized electronic systems. So for example, on our next slide here on the bottom right, we have applications in healthcare. So You see that there's electronic medical records. Also these things called like PACS, which are picture archiving communication systems. So things like sonograms or x-rays that have to be archived, annotated, sent. Sometimes in the case of like radiology, maybe even automatically categorized or perhaps even computer-assisted diagnoses through these computer systems. And so there's a massive amount of computer science applications in all sorts of fields. And you don't have to be just a hardcore engineer. It can be like a very, very everyday thing. You go to your nearby grocery store, they have like a point of sale system, or like maybe you have a high tech like Amazon grocery store where you can just walk out with your groceries. That kind of stuff requires all of these systems. At the top here, we have a slide on farming, which we thought was a particularly kind of funny thing, because I guess farming is thought of as a very old-fashioned field, especially when you look at a documentary. It looks very archaic. May even have like, some technology like trailers or like tills or like irrigators, but that feels like 20th century technology, not 21st. But at the top right here, you have all these tech companies. They're doing agricultural analytics. They're doing soil testing. They're doing distribution. They're doing genetic testing. They're doing how to minimize pesticides by only applying it on certain places. Maximize irrigation and maximize other kinds of like nitrogen fixing, for example, without having to apply it everywhere and damage the environment. So across the supply chain and across the infrastructure system, we see CS being applied on something as simple as farming. I know when I was driving in California, I was shocked. You could drive for like hundreds of kilometers, I guess miles, and not see any people, just see farmland as far as you can see. And the level of mechanization automation that allows us to, have such amazing groceries and have them not be so expensive and whatever, it is being done not just through 20th century automation, not just factories, but also through these digital innovations. And so I guess like Vikram and Sidharth, I think we're getting close to the end of our talk here. You guys are about to start school, and it's probably pretty hard to balance your schoolwork and also all these activities and all these future plans. As a student, like, it seems almost intimidating. Like, this is like high tech stuff that we're talking about here. Like, how do you deal with that? How do you like on a day-to-day basis and throughout the semester approach learning CS, right? Even though it looks so advanced. I mean, you guys are obviously doing it, so can you share your secret a little bit, I guess, with the audience?
Right. So I feel like it's easy to learn CS, especially as a student, because it may seem that boring and like just like such a crazy and complex topic, but in reality, like it's really stuff that you've seen in your day-to-day life. Like, for example, say a computer program creates a matrix or something like an array. In school, you can learn about matrices. And if you look at things like arrays or other computer science structures, you'll see that these things are actually similar to things you're learning in school. So I feel like if you're a student,
and you're talking about math matrices, right?
Yeah. Yeah. So if you're a student, like looking at like if you're just maybe a student or even an adult, like seeing stuff having stuff that you see on a day-to-day basis definitely helps you with computer science. I think school and computer science, they definitely tie in together.
So do you have to like do you ever use CS as part of like your math class? Like, do you have a programmable graphing calculator, or like you get to use it as part of projects at all in school?
Yeah, definitely. I think math is probably one of the biggest places where we use computer science. But even places like biology, that's another place we use computer science. For example, we one time wrote a computer science program to look through the different genomes of mitochondrial DNA in like a polar bear and a grasshopper, and to see all the mitochondrial DNA differences and see how closely related these two animals can be.
Okay, wow, that's really interesting. And I remember one of our students, I think he was doing like a French paper, and then I think this is actually really cool. He wrote like a program that, as part of the French paper, did some analysis of like 2 different authors. It was included that as part of the French paper. Certainly there's some like, and that's perhaps why he studied humanities and computer science at the MIT Media Lab. I think we're starting to round up on our time. So unfortunately, I don't think we'll be able to go much further. Were there any questions on the right side, or do you guys in the audience have any questions for us in our, our 2 middle and high school panelists today? I'll let it propagate a little bit because sometimes it takes 10, 20 seconds for these words to be sent over YouTube. Any questions? Okay, so I guess we're not getting any questions right now. So I guess, Sidharth and Vikram, do you guys have any final words for our audience here?
Yeah. So basically, a lot of people think that computer science is just typing out code, and I think from this talk, the obvious answer is that it's really not. And I think there's a way to really experience this firsthand is a class here at KTBYTE, the Robotics Club, the KTBYTE Robotics Club. And in this class, what we really try to focus on is building different like robots or different not even just devices that can solve everyday problems you see in your life that use computer science. So for example, there is a rover that can go, I want to build a rover that can go around and actually spray water on a fire to put out the fire. And another one is even checking to see if your garage, just like simple things, checking to see if your garage door is open, so that it will notify you, so that to make sure that robbers don't come into your house. And it's these practical applications that you can take computer science and you can build something with it to really create something meaningful that can benefit the world. And people think, oh, I'm just going to be sitting at a desk all day and doing stuff. But honestly, a lot of it's trying and testing new ideas and building new things. And that's really the benefit of using computer science.
Yeah, so also people think that computer science may be intimidating, so they want to start with it. But if you don't know computer science, you're not going to immediately jump into, I don't know, artificial intelligence and learn that. Instead, you should take it one step at a time. Learn for loops, if statements, arrays, then you'll go further in, and then you will be able to do maybe artificial intelligence or data structure.
And Sidharth was talking about in-person classes, but I guess you're saying also you can just learn this at home or online, right?
Yeah, you could sort of just learn it. I started to self-learn, and then I took KTBYTE classes. But yeah, you can sort of learn it one step at a time, and then you do advanced stuff. So it's not as intimidating.
Okay, great. So I guess we did get one question, which was, can I be good at CS if my math is not amazing? Do you guys have some words about that?
I would say that computer science is definitely based on math, but at the same time, I would say that you don't have to be a super genius in math to succeed in computer science, because a lot of computer science is
a different kind of math.
Exactly. Right? Yeah, it's not I don't know, solving equations and doing this and that. It's a lot of the bigger topics in math, bigger ideas. That's kind of what computer science is based off of.
Okay, so I guess to put it discreetly, you're talking about things like understanding information or variables,
exactly,
or logic, or being able to see how one piece of information impacts another piece of information, or following traces of information from one thing to another, right? Like when you're debugging, or when you're looking at how a variable is used in a lot of different situations. But I guess you wouldn't say they need like geometry or calculus or like that kind of stuff.
Yeah, I think maybe later on you might, but at this point, like just to understand computer science, like unless you want to go into deep coding and machine learning networks, I think maybe at that point mathematics is important. But just to understand a general idea of computer science, like math.
So like when you say generalized idea, I mean like I guess you're saying like the first few years of learning.
Exactly. Yeah. That like math is not entirely. It's not like you don't need a large math background, like a big math background to get through computer science.
Yeah, and I remember when we were teaching, even like volunteer classes, there would be students who haven't even learned algebra, and they would be able to do fine in classes.
Yeah.
And so, yeah, I don't think you should be intimidated if math is something that is difficult for you, because a lot of school math is about doing specific types of problems. While computer science, sometimes they call it discrete math in the sense that it's using kind of similar parts of the brain, but it's not like if you do poorly on your math homework, suddenly that's going to translate immediately.
Yeah.
Okay. Well, I guess that's it in terms of questions. So thank you very much to both our two panelists here and also the audience. And if you have any further questions, you can email us or visit the website. And yeah, we'd be happy to hear your thoughts and continue the conversation. This is hopefully the one of many opportunities for students to talk about their experiences, share with the community, and try to foster just a greater sense of how CS can benefit both themselves and others. And so I think we're really happy to have Sidharth and Vikram talk about that, and we really hope that this is something that spreads to other students and people in other communities as well. So thank you very much. And yeah, I guess there's no questions, so bye-bye.
All right, thank you.
Thank you. Bye.